Um, hey guys, I've just been looking into how antiviruses work and that, so we're going to be talking about how to bypass them. Now, there's there's three sections to an antivirus, right? There's signature, there's heuristic, I don't know how to spell it, and there's dynamic. So, what signature is it's really just an AOB scan. Man, I can't type. It's an AOB scan. It just checks for known patterns. So, if you don't know what an AOB scan is, basically it just checks for a pattern in the binary to see if it has known malware in there. So let's say known malware has like a, I don't know, an opcode like something like that, okay? Really weird. You wouldn't, hang on. Okay, you would not find this in a standard application that's being compiled, because the compiler would optimize this, and maybe the no-ops are like a patch for a game so that you can pirate it. So this would probably get flagged. I don't really know. But if a known malware sample had this, and that's what makes it the malware, then if they see this in your code, then it'll just, flag this malware. Heuristic. That is not how you spell heuristic? Okay. It's also static, like signature. I should also write static. And what static means is it just analyzes the binary. It doesn't actually run it. It doesn't actually, see what it does by running it in a sample environment. It doesn't emulate the assembly or the opcodes. Doesn't do that. It just, I guess it looks for certain things, such as keylogger. Keylogger would have the keyboard hook proc, which it's not in here. Just wait. Just go to Arsenal because I'll need this later anyway. It would have keyboard hook proc, this, L result callback, this. And then at the end of it has return call next hook X. And this is something that, keyloggers typically have. It's the easiest way to make a keylogger. You could do it with get async key state, but it's a little bit more sketchy, it's more annoying. This is the easiest way to do it. So, if it sees a keyboard hook proc, it would probably mark it as a keylogger. I don't see why it wouldn't, because normal games probably wouldn't. I mean, would they have a keylogger? I don't even know. Anyway, if they see this, it's going to be marked as a keylogger. So it looks for certain things, such as a keyboard hook. I guess certain WinAPI events, so if it's injecting a DLL, I guess it would this doesn't have any DLL injections. It would, flag it. If it injected into calculator or something. Can you even do that? I don't know. Something that's always running. Injecting into Explorer. Yep, Explorer. To bypass user admin control, which is the admin prompt. You can inject the DLL into Explorer, or inject code into Explorer to bypass that. That's if I recall correctly. They probably fixed that in Windows Defender, but you know, looks for certain things such as a keyboard hook. It probably looks for copy file A as well, and the reason why is because that's how I do persistence, at least. This is like part of my malware I've made, and there's the destination path. It goes to this string. So if it sees like copy file A from itself. Wait, how's it get the bloody source files? Buffer. Okay, so if it sees this, and then it says like copy file A from itself to the destination that is a startup folder, then it would flag that. Actually, it might be dynamic. No, it's probably both. It's probably both. This one is dynamic and heuristic, I'm pretty sure. Wait, I'm gonna ask my good mate ChatGPT for this one. Just because I genuinely don't know. It's probably gonna say something like, yeah, I don't support making malware. Like, shut up, bro. Anyway. Right. Okay, so if the source or okay, whatever. So this is dynamic heuristic analysis. Oh wow, okay. So basically it is both dynamic and heuristic. So I was correct. That's quite interesting. Okay. That looks suspicious. Yeah, this would look pretty suspicious. So this would be heuristic and dynamic. And so copy file A from itself to a startup directory, and dynamic, which is the more fun one, I'd say, is just actually running the code, the in a test environment, just actually running it, and it monitors stuff like persistence, you know, would monitor keyboard hook, it would monitor dropped files, would monitor read files, I guess. It would monitor basically everything it does, okay? Just anything it does. If it does something with WinAPI, like if it write process memories to Discord, it'll see that. I mean, wait, no it won't. If it write process memories to because it's in a test environment, it won't have Discord open. What's something that's just like always open? As I said earlier, I mean, what do you... I don't know anymore. Like Explorer. Explorer is always open in the background if you didn't know that. Don't close it. You don't want to. And that's what dynamic does, that's what heuristic does, that's what signature does. Now, signature is pretty much a joke, okay? If you get detected at signature, you're an actual idiot. Like, if you're doing something like allocating code to a buffer then executing it, bro, just encrypt your code, encrypt the yeah, just encrypt the code and then decrypt it before you need to use it. Like, signature is not an issue, alright? Heuristic and dynamic, now these are the real issues. Now, I've got something, I've made something, a little something, alright. It bypasses heuristic detection, and I've also got a dynamic bypass in there. Now, it was pretty interesting to note, but just be careful because some dynamic bypasses, where it actually runs the exe in a test environment, some dynamic bypasses are detected at heuristic. So, an example of this, I'm guessing the allocate 100 megabytes, the good old allocate 100 megs. Is this something? Okay. So this guy's using create remote thread and write process memory into another process. I'll probably get detected at heuristic. What the hell is this? Okay, this. Alright, this is a classic AV evasion trick, as they say, where they just allocate like 100 megabytes of RAM and then free it straight away, and then do this. This is because dynamic, basically, they have limited resources to work with, alright? You're not gonna be allocating bloody 16 gigabytes each time you want to dynamically scan something. Like, it has very limited resources to scan files with, and it needs to scan like thousands of files on your computer. But this, if AVs have wisened up, which they really should have, this will get detected at heuristic. If you malloc like tons and then just free it, it'll probably get detected at heuristic, which is something to note. Now, so signature, how you bypass it is basically you just encrypt your stuff, alright? I mean, even this guy did it, I'm pretty sure. No, it says, not encrypted, without encryption. So this will get detected at signature, because it's not even encrypted. But the heuristic, I mean the dynamic, won't get detected at dynamic because of this. Alright, and it says Trojan, malicious, unsafe, Trojan, whatever. Actually, let's go and see this. Oh, what? Did my guy link the right one? Okay. Injector? Yep. Yeah, it is shellcode. Okay, this is the right one. So, that bypass that he tried, the memset 100 megabytes, that is detected. By far. Okay, it's not even a joke. They've all detected it at heuristic. And maybe signature, because he's an idiot, but I don't know. Yeah, signature match, this guy's saying. Alright. Anyway. Yeah, so some dynamic bypasses can get detected at heuristic. Now, we're here for bypassing. I've said signature. Heuristic bypassing. That's... Well, you know, we'll start at dynamic, okay? We'll start at dynamic. Now, what I've done for here, AV bypass dynamic. So, ignore this, ignore a lot of this. We're just gonna worry about like this section, okay? So, okay, what this does is it basically wastes CPU time. I've done it in a little creative way. So it puts I here so that we can use it outside of the for loop. Duration just so that I know how long it is, don't worry about that. This is where the CPU time gets eaten up. It takes about 1 minute for my CPU. Single threaded, and when you're doing this dynamically, when you're scanning this dynamically, you're not going to have a full thread to yourself. I wouldn't think so. You'd have like barely any resources. And dynamic, they really only run it for 15 seconds, I'm pretty sure. Something like that. Because, you know, you have to scan other files. So it just keeps adding itself by this, and also incrementing for no particular reason, whatever. I just left it how it is. Eats up CPU, basically. Then once it's done, you know, it tells you the time taken. Don't worry about this yet. Then, only if I equals this, it'll run the encrypted function. That's so that we use I, so it has to run this. If we don't use I after this, then why do you even need to run it? It can just skip this. It can just skip this for loop because you're not using I. But since we're using I here, it cannot skip the for loop because otherwise I will not equal this. And it will not run the encrypted function. And you might be like, well, couldn't you just do like a sleep, I don't know, bro. Something like that. It's like sleep 15 seconds, because I said it was 15 seconds. We're going to stick with that. For one, this will get detected at heuristic for long sleep times, and it will just be bypassed at dynamic. Okay, they don't care about sleeps. They don't care. They just skip the sleep. They've wisened up to that. So this is the dynamic bypass. Sadly it takes a minute, which is annoying. I'm gonna make it take 10 seconds for a normal CPU, because otherwise, you know, it won't add persistence, it won't, you know, anti-task manager, all that good stuff. It won't do all that, because it hasn't, you know, it hasn't wasted enough CPU time. So you gotta make sure this is short, but not too short, okay? That bypasses dynamic. Now, the main issue, like once you've done this, is heuristic. Heuristic is scary. It is... This is where you get detected, alright? If you're getting detected at dynamic or signature, you're really doing something wrong. You just have to switch on your brain, and then you won't get detected at these ones. Alright, heuristic. Now, how I've done this personally is basically I've made something. Okay, how do I explain this? Okay, so I'll just show you how this works. I'll make sure that nothing crazy runs when what? Okay. Nothing crazy runs, so thread 1 adds persistence, and this one... What? Okay, yeah, I commented out thread 0. So it just adds persistence, which if you remember, it gets detected at heuristic and dynamic. Okay? Now, I actually did 2 persistence paths just to make sure that the antiviruses, you know, make sure that they know that I'm copying to a startup directory. One of them, shoutouts to Nosh, gave me this path. I mean, he didn't give it to me, he just gave me a bit of his Python malware. And then I saw this path and it was pretty cool. Never seen it before. But this one is pretty well known. This path. By the way, if you're confused, .scr is a screensaver, and screensavers behave just as exes pretty much. So dx3d underscore render, that'll scare off anyone, they won't delete it, hopefully. That's what we want. And screensaver.scr, that'll also, you know, scare off people, they wouldn't want to delete a Windows file. And basically just copies itself to these paths, you know, nice and simple. Gets detected at heuristic and dynamic, but we have a dynamic bypass, which is this. So we're just stuck on heuristic. Also the long sleep time, that's heuristic as well. Just to make sure, you know, it's heuristic. Like, this is blatantly obvious, it's gonna be like an attempted dynamic bypass. Anyway. I've made sure that this program without any protection would get detected at heuristic. But if you've noticed, there's these ill-defined for loops, which you need optimization off for it to work. I also use C++14 and Unicode character set. I can't change the C++14 because the starter marker, this will compile to I genuinely don't know where the signature is. Okay. This will compile to this signature. Okay. This is the starting marker, because you won't see this anywhere else in the program, because this is just stupid. It's an ill-defined for loop, and it's got nothing in it. Okay, you would never do that in a program, which is why it's good for a marker, because you can scan for the for loop, basically, then you'll be like, oh, that's where it starts, okay. Then you scan for another for loop, which this time has 0x1000 instead of 0x777, which is slightly different. I mean, you can look at the signatures, they're not too different. This is like, no, I won't explain it, Anyway, signatures are slightly different, and they mark the start of where we want to start encrypting and the end of where we want to stop encrypting. Because if we encrypt main, well, it's GG's, bro. Like, it's not gonna run. But if we just encrypt the function with this, then this to know where the start is and where the end is, then it's all good. I'll go a bit more into depth about the encryption. It's a very, very small function, you'll see. So basically, it signature scans the file that it's... Okay, wait. Before we do this, I need to... Just wait a second. AV bypass, then underscore random. Okay. Copy, paste. This is how it patches, by the way. So this one will be running, which will patch this binary. Alright. And then this binary will have the encrypted function saved to SSD. It's not in memory. It is actually patched. Okay? So when it runs, it will have to decrypt itself at runtime, otherwise it'll execute encrypted code. Alright, that's how it works, just because you might be a little bit confused. I accidentally opened Steam. Great. We'll just wait for it to open. Anyway, so you copy itself, and then it patches its second version of itself, the copy. This is the one that you want to give to people. Alright, this one's the malware, this one's just the setup. And I know that I just copied them over and they're like the same binary, because I just copied them, right? But this method nops the call to itself, and then encrypts the file so that it can be decrypted at runtime. So what this does is it opens this, okay, does a whole lot of SIG scanning, you know, it no-ops the call to this function, and this function is called here, and then when it's called it will return, and nothing will happen. Okay, it's just the setup. Setup flag is 1 in this function, and if setup flag is 1, it will return. So on setup, it basically nops the call to itself, so setup flag will not be 1, it will continue and it will run. Okay. This one is gonna run if I double click it. This one, it's just the setup. Now, you might be wondering, well, why do you need to encrypt the binary? Why do you need to do all this? Why do you need to nop the call to itself? All that. Now, back to here. Now we know signature is static. This is also static. Should have written that. And, you know, it checks for known patterns. Now, since when we analyze this, okay, like statically, the function will be encrypted. This function, alright? You are not going to be able to read this. It is going to error if you run it. Like, not even error, it's just going to crash. It's going to be GG's. So, basically, since heuristic is static, there might be dynamic heuristic, I'm not sure. Anyway, since it is static, and it looks for certain things like copy file A, and it checks if it's like suspicious, if it's copying itself. But since the copy file A call is encrypted, because it's in the encrypted function, all it's gonna see is a bunch of opcodes that will error. And it's gonna be confused. It's gonna be like, well, maybe the file's corrupted. Well, we know the file's not corrupted. Okay, the file is just encrypted because we've patched it. And then at runtime it does the AV dynamic bypass, nice and simple. Then it does this, XOR sigmem, which basically decrypts, I'll just make it very simple, it decrypts the function with the end marker and the start marker, just like the patch file thing did, but this time it's in memory. It's not on the SSD, it's in memory, so it's temporary. It's not permanent. It's just at runtime. And you might be like, well, if you decrypt it, can't heuristic see it? No, because heuristic is static. Alright? I mean, there might be dynamic heuristic, I still don't know. But you might be like, oh, okay. Well, can't dynamic just see the persistence, the drop files, you know, the red files when it's run in a test environment? That's what we have this bad boy for. Bypass dynamic. So, basically it decrypts it. I won't go into the function details. If you want a video on that, sure. This is just for me debugging in x64 debug, which if you don't know, it's a very good program if you're doing this. And it checks if this was actually skipped or not, so that, you know, the dynamic can't skip it. Then finally it executes the function that has been decrypted at runtime, so that, you know, we can do our malicious things. And then it will copy file all that good stuff, okay? Alright. So we've done a bit of overview of the code. What does it do? We'll just recap. This is just the setup, just to encrypt the file, like on disk. This is the antivirus bypass dynamic. This just decrypts it in memory, in the RAM, not on disk, so that it can't get detected by heuristic. Then we just execute the function, and then that's it. So you might be like, well, does this actually work? Is it effective? We have sleep, long sleep, which will instantly get flagged. We have two different two different persistence paths, so it should get flagged by heuristic, right? And also dynamic, but we've bypassed dynamic. Should get flagged by heuristic. Let's see what it does. We're gonna run this. I mean, no, we're not gonna run it. What? We're going to patch it. Patch me AV, so that we get the encrypted one and not the setup. And then when we go to virus total, we go to this, and if you, okay, just believe me that if you right click it, run with admin, it will, okay, it will copy files, like copy itself to startup folders. And it also has a long sleep, which is very obvious, detected at heuristic. Now, let's see what it does. Is it detected at heuristic? Actually, I don't know why I'm doing this. I have a screenshot of the result, but the suspense is nice. Ooh, 3 out of 61. Ooh. Ooh. Where's BCAV Pro? Where's it at? Nothing gets through BCAV Pro. I'll explain to you why. There's 3 that have detected it. Wait, didn't I already... Okay, whatever. BCAV is taking a while. It's an AI one, which absolutely sucks. Yep, there it is. Ha! Okay. So we go back to this. Normal C++ app. Okay, this is the scan of a normal C++ app. BCAV Pro, Google, Icarus, and Max Secure. Keep those 4 in mind. BCAV Pro, Max Secure. And Icarus did not detect it, good. Elastic is also a schizophrenic one, but... Icarus and Google. Yes, they did not detect this one, but they detected a standard C++ app. And the standard C++ is this. You can read through it if you want. I can run it. You know, no harm. It's just I just did something for a little bit of math, a little bit of fun. And it's detected by 4 different antiviruses. Sad. Sad, okay? But it's just the way the world works. So really, this one, don't worry about it. This one, don't worry about it. Signet and Elastic. Those are also very schizophrenic ones. But I don't really have anything to prove it. But just take my word for it, okay? Signet and Elastic actually suck. They always detect just random stuff. So self-modifying code. Okay, so this is the antivirus bypass without any virus. Alright? And would you look at that? Bcaf Pro, Signet, Elastic, Max Secure. Doesn't that sound familiar? Bcaf Pro, Signet, Elastic, and Max Secure. So the detection rate does not change if you put a virus in it. With keyboard hook, yeah, I wouldn't count that. With persistence, okay. Which is, this one is with persistence, right? Yes. With persistence, it's the exact same without persistence. Which means our bypass has worked. It doesn't even say that it's... I don't think it even says that it adds no, it doesn't even say that it adds persistence. Wow. It does not say anywhere. There is not a trace. Not a trace. But if we... Okay, let me just get my one without protection. Let's go to Arsenal. This is my malware without any bypasses. None of them. Okay, so we're going to... Oh, there is a dynamic bypass. We'll leave that in there. We're going to literally comment out everything but persistence. Okay, this is just troll malware, by the way. It's not actually like nefarious. So it's gonna add persistence. Let's build it. It's got no protection apart from this, which is dynamic dynamic, what's it called, protection. I really can't speak right now, so just give me a break. Arsenal.exe. This should be instant. No, it's not. Okay. We'll just wait for this, because I haven't screenshotted it. Let's see how many it gets. Oh boy. Oh boy. It is detected. So wait, what even is this? So okay. It's being falsely accused as a Trojan. But still, it's pretty much the same thing. The persistence method is the same. But this time, it does not have the code encryption. There is no code encryption, there is just the dynamic bypass. So, I'd say that this This is quite worse than this. Like, and these ones don't count, okay? I mean, correct me if I'm wrong, but these ones are really, really sensitive in heuristic detection. And I know I did bypass heuristic, but they probably... I mean, didn't they... BCAV, forget about it. Google, forget about it. I'm sure... Okay, Icarus... I'm surprised Icarus didn't detect this one. Because it's very... It must be terrible. Must be awful. Max secure? Get out of here. Wait, that's literally flagged with the same exact thing. Look at this. I have no idea what's going on with that. Maybe some includes. Maybe they're detecting the includes. Because I include windows.h. And it probably just detects it at that. Oh, imagine. This doesn't even need windows.h. Anyway. So it's safe to say that encrypting the code on the disk and decrypting at runtime definitely bypasses heuristic. And you can do anything in this encrypted function. Pretty much. If it's outside of it, like keyboard hook proc, it won't get encrypted, it'll get detected. Because it'll still see like everything in here, but it won't see the call to it. Wait. Am I dumb? Yes I am. That's not how it works. No, it'll see this and completely unencrypted. So you can do something like get async key state, because that's in windows.h. Make a keylogger with get async key state, and in the encrypted function, and you'll be fine. It won't get detected at heuristic, it won't get detected at dynamic, and it won't get detected in signature because the code's encrypted. This bypasses all three metrics. All three. This be the code. That's just little kid made. Bypasses all three metrics. And like once you're in the encrypted function, like you can just do anything you want. Anything. Because copy file A and sleep both are very, very, very obvious in heuristic detection. I mean, I just showed you how obvious it was. Where is it? 13 out of 72. And I'm not sure why it flags it as a Trojan. Because it's definitely not a Trojan. I mean, I just made it. No, not this. This. I mean, it adds persistence. Maybe it's just flagging it as a Trojan because it has persistence. But they're very obvious. And wait, does Microsoft seal it? Oh my god. Microsoft doesn't detect it. What is the Microsoft antivirus? Is that Windows Defender or not? I don't know. Anyway, it's just something pretty cool that I found. Straight up antivirus bypass. I will definitely be porting this entire thing, all this good stuff, to this one. Just because it won't show up as much as virus total. Actually, it really should have something on the sandboxes. I haven't seen anything in the sandbox saying like it dropped a file and bloody... Maybe it's because the CPU that it has like takes 5 minutes to do the do this. Maybe, I don't know. Anyway, that's an example of how to bypass static, I mean not static, signature, heuristic, and also dynamic. And I will be uploading this AV bypass, this exact thing, to GitHub, just so that, you know, you can see how it works. If you really want to see how patch file works and XOR works and you know, SIGScan and file to memory, you want to see how all that works, sure, go ahead. Other than that, see you later. Hope you learned something. I hope you learned how to, I don't know anymore. Just I didn't even, I don't know what to say. Anyway, I'm sure I was meant to say something. Right? No.